Okay, so for the en route performance planning, we're looking at engine power settings, fuel flows, and we're going to yield us our true airspeed, which is really important, and our gallons per hour, our actual gallons per hour, based upon our power settings, RPMs, manifold pressure, and mixture settings. So we're going to get a lot of useful information. We've already worked with true airspeed and gallons per hour and fuel and all that. Those numbers don't just come out of thin air. We actually have to determine what they're going to be using the Diamond information. So Diamond's got, this is 2 pages actually, so this first page shows different power settings at 45 and 55%, and on the next page it's going to show higher power settings at 65 and 75% engine power. So we're going to choose one of those before we start, and then from there we're going to have a couple options as far as how we set this up. So on the next box down, we've got options for RPM. So we're going to manipulate that RPM propeller governor to set for 55%, either 2,000, 2,200, or 2,400 RPMs. And then our manifold pressures are going to be determined by our altitude below. So we'll see that in just a second. So let's just run a scenario where we're going to set 55% power. And while we do that, we're going to actually choose a best power mixture. And let's say we're at 5,000 feet. So what does that really mean, and what is this chart giving us? Well, we know if we're at 55% power, let's choose 2,200 RPM. There's 3 options, let's just choose that. Based upon that, if we choose to set the mixture via best power, which we'll explain in class, we know then that we're going to achieve 8.5 gallons per hour in cruise. And so that's where we get our GPH from. It's a very important number, and we base all our fuel planning upon that consumption rate of 8.5. Okay, well, that's great. We have one more thing here, which is our manifold pressure. Well, I mentioned we're at 5,000 feet, so we're just going to come down on our chart till 5,000 shows up, and we're going to see where 5,000 corresponds to that RPM, and we're going to set 20.9 inches of manifold pressure to achieve that power setting at that altitude. So 2,200 RPMs, 20.9 inches of manifold. We take note of those because that's what we're going to set when we go to set cruise power after our climb. And we also know we're consuming 8.5 gallons per hour if we set it all up properly and lean it properly. So that's how we choose a power setting. And you'll see as we go higher and higher in altitude, we're unable to actually achieve higher power settings because the power available decreases as altitude increases. So for 65 and 75%, you can clearly see even at throttle wide open, we're not able to achieve certain power settings at higher altitudes. And that should correspond with what you know about engine performance as it relates to altitudes. So let's take those numbers and do one more thing. Back to our original numbers at 55%, 5,000 feet, we saw our power settings there. We then used that selection to find our actual true airspeed for a given flight, provided all the other information. What we're doing here, and you see they use the same numbers we've mentioned, finding the cruise pressure altitude, noting the cruise temperature, in this case is 15 degrees, and our power setting is 55%. So let's say cruising at 5,000 feet, though at this point you should know that's not a VFR cruising altitude, but let's see what we'd get with true airspeed. You can follow their example here, and just like with many of the other charts, this first box is just a density altitude box. It's a pressure altitude and a temperature. So they started at the cruise pressure altitude of 55%. You can see where they start here. And they're going to come across until they hit the cruise temperature. The cruise temperature is 15, as noted by this line. So those two intersect right about here. And notice what they do when they hit that spot. At that spot, they're going to pivot and follow the guidelines just like on the other charts. So you can see their line comes downward until we get to this point. Once we hit that point, you can do like we can with everything else in these plotters, just pin it and go straight across as they did. And the last part is a little easier. We're going to go across till we hit our power curve. We see 45, 55, so on. Go to the right till we hit our 55% power, so you see they've done that. Come straight down to see our planned cruise true airspeed, which in their case was right here, which corresponds to what they found of 118 knots. So from that information, guys, we're getting percent power, RPMs, manifold pressure, fuel flow, and true airspeed just from those 2 pages. And if you take your time and do it correctly, you shouldn't have any problem.